All right, so we were talking about motion. So yesterday we talked about how fast something goes, would be called its velocity. But now what we're talking about again is the change in its velocity. So again, we said that Donovan's going to run a lap around the track. What we can do when we get those different times of Donovan's lap around the track, we can calculate when he started running. Well, I'm pretty sure he's not going to pick up speed, all right, because if he starts running, he's probably going to slow down. But we can see how much does he slow down compared to the first half of the lap, as opposed to when he's running that second half and he's really going to slow down and he starts to give out. All right. That change in speed, or that slowing down, we call an acceleration. So an acceleration, simply put, is going to be a change in speed. All right, which does describe motion, which is what we're talking about here. Again, this unit is called motion and forces. Right now we're focusing on the motion part, the movement. All right. One of the things we talked about yesterday with movement was distance displacement. We said that displacement was how far off from the original point you were. That was your displacement. That describes the movement. Because again, if I'm not standing, like right now I'm standing on this end of the counter. Okay? So when you look at me, I'm on the end of the counter. If you didn't see me move, like let's say you were some people and you were just sleeping for about 10 seconds, and then you opened your eyes, and all of a sudden I'm here. Well, if you didn't see me move, how do you still know that I did move? Uh-oh, that went deep. All right, let's try this one again. Okay? You know I moved, but you didn't see me move. So how do you know that I moved? Okay, because I'm at a different point of the counter, right? Earlier, I was on that end of the counter. Now I'm in the middle of the counter, right? So you had a reference point, like the counter being your reference point. Because I'm in a different spot, that's why you know I moved. Okay, that's as simple as it is. So you have to have something to have a reference point. Again, reference points can sometimes screw you up. I don't know if some of you may not drive, but sometimes when you drive and you're at a stoplight and maybe you're kind of looking down at your phone or you're looking out, you're not really paying attention, and then you see that car start to slide, right? And then you think it's your car moving and you slam the brakes even harder because you're thinking you're moving, but it wasn't really you're moving, it was the car next to you was moving. That's sometimes when you get your reference point a little bit mixed up in your brain. Because you just, but again, if you've never driven, then you don't understand that aspect of, oh my God, I think I'm rolling into the car in front of me, and it's not you moving at all. It was just the car next to you is rolling forward because you were at a different stoplight. So, change in speed describes the motion, all right, for an acceleration. And so the one thing we need to make sure we understand is this. Acceleration, all right, it can be positive and it can be negative, all right? You can have a positive number acceleration. Like I can have, if somebody says it accelerated at 2.5 meters per second squared, that lets me know that it's sped up. So a positive acceleration means speeds up, okay? Which is what you typically mean by accelerate, all right? So usually when you say something accelerates, usually you mean it speeds up. But scientifically, what that means is it has a positive acceleration. Because you can have something slow down. What do you normally call it when something slows down? That's 2 words. Some of you wouldn't use 2 words to describe something that's 1 word. Anybody know? Like you don't call it accelerate when you slow down. You call it what? Okay, maybe you don't call it anything. Sorry. Most people call it decelerate. Okay, they're decelerating. Okay, and so, but the point I want to make sure you understand here is this. In science, when we're talking about measuring things, we don't use the word decelerate and accelerate because we're going to know that by the positive or the negative. So if I see a negative acceleration, then I know it's slowing down. When I see a positive acceleration, then I know it's speeding up. Okay? So if I go and I calculate Donovan's change in speed, if the change in speed gets me a negative 1.5, then I know this. He slowed down. It don't got to tell me he slowed down because once I see negative, I know it slowed down. If I see his acceleration is 2.1, it doesn't have to tell me he sped up because it's positive. I know he sped up. So that's something I want to make sure you realize. Okay? I want to make sure you realize when you're doing your math calculations, you can get negative numbers. All right. Yesterday, when we were talking about distance, remember I said you can't get a negative distance because it's either like you're either 5 feet that way or you're 5 feet that way, right? You have a direction, but you can't go back negative 5 feet. So, but in acceleration, you can go back. You can't have a negative. Okay? That just simply represents a slowdown and a speed up. Are we good with that right there? All right. So the unit of measurement, I mentioned it yesterday. The unit of measurement for acceleration is meters per second squared. It looks very similar to the unit of measurement for velocity, which yesterday was what? Meters over seconds. So again, where you're going to get confused unless you memorize this is you're going to say, you're going to write down a problem, all right, and you're going to see in the problem velocity, all right, and then you're going to write your answer and you're going to put m over s. But the question is, should it have been m over s squared? Well, that depends. What were you solving for? If you were solving for acceleration, you should have had m over s squared, all right? But if you were solving for velocity, then it's just m over s. But you got to be careful if you give me that 2 or not. Now, if you look at your reference sheet, all right, I want you to look at your reference sheet. So go ahead and take that out right now. Because, again, we're about to look at that formula anyway. So we're about to look at the acceleration formula anyway. So when you look at that reference sheet, all right, you're going to see, you're not looking at the far left side. You're looking at the middle. Okay, where all those variables, where they tell you what all the letters stand for. You're going to see one about halfway down, okay, that says G. All right, and it says G, and then it says acceleration due to gravity. Do you see it? Now, if you keep reading that line, it gives you a value for that acceleration due to gravity. 9.8, and then it says, correct me if I'm wrong, it says m/s/s. Is that correct? Okay. I want to make sure you understand that m/s/s is the same thing as m over s squared. It's the same thing. Okay? So I've seen them give you those units. Sometimes I've seen them give it to you this way. Sometimes I've seen them give it to you this way. And so now what I need to do is I need to prepare you, because if this is the year they do it the way on the right, then I need you to be familiar with that, because if we do it this way in class, later on that may not make sense to you. All right? Or flip it. If this is the year they do it that way, then if we've seen it like this, then you may not recognize it. Where if I just teach you both ways, then either way you're ready. Okay? That's what I'm trying to go for here. Get familiar with both ways, so that way either way you're ready. Okay? Any questions right there about what we have with acceleration? It's a simple topic. Because yesterday we took our time with displacement. That helped us get faster through speed. And then with speed now we know that a change in speed is an acceleration. So all we need to do now is just kind of know, well, how am I going to measure acceleration? Well, for something to change, think about this now. So we're about to get deep again. For something to change, what would you need to know? Okay, think while I erase the board. Don't say it out loud. For something to change, what would you need to know? Or I could ask it a slightly modified way. If something has changed, then what would you need to know if it's changed? All right? Who can volunteer some information? Help us out with this thought. Donna?
How did it change?
How did it change? Okay, well, how would you know? What would you need to know how did it change? Holmes? What was it before? Okay, so what was it before? What else would you need to know then?
I'm having trouble with connection.
I know you're not used to sitting there. All right? But I can't help you with that. All you have to do is place it on top of your table. All right? Okay. Go ahead.
How do you see what caused it to change?
What caused it to change? Okay. Yes. All right. Let's go back to Holmes' idea. She says we need to know what it was before, right? What else would you need to know?
What was it after?
What was it after? Right? Like, in other words, ready? If I go over here and I say, hey, ready? This is what slim fast looks like. Okay? What would be the first thing you'd want to know is, well, what did he look like before? Right? I mean, if that's the after, then what was the before, right? Because then if the before looked just like this, you'd say, well, slim fast sucks, they don't work. Right? But if I were to say, no, there was a major difference, then Lord, how big was the man before? Right? That's what you'd have to know. So again, you do need to know a before and you need to know an after, right? So if we're doing acceleration, I need to know the before. What would be the before? Remember, acceleration is a change in speed, right? So what would be the before? The speed you started with. Good. And then you need to know the after. All right. The speed you were after, right? Like, what are you doing now? Okay. So if we look at our formula, this is the formula we're looking at here now, okay? It's the second one from the top. How many velocities do you see? 2, right? And guess what? One's the before and one's the after. So for us to know a change, we have to know what was my starting and what was my ending. What was my before? What was my after? Well, that's exactly what the formula says. The formula says this. A, to calculate acceleration, you need to know the initial velocity. VI stands for initial. Now, because I've been teaching at North Pitt for a long time, here's what I know. I'm going to go with this. About 15 of you in this room don't know what initial means. So therefore, let me go ahead and tell you what initial means. Initial is my before. Okay? Or we can say it's my starting velocity. Got it? Now, I don't care if it's the starting, the middle, the end, or whatever. It's a velocity. What do I measure velocity in? You all can say it. Don't be afraid, sir. Meters over seconds. So again, what am I going to look for in the word problem? If I'm solving for acceleration, I'm going to need to find the meters over seconds. And when I do, I'm going to know it's a velocity. The problem will be, is it the initial velocity or is it the final velocity? All right? And this is where some of you are going to zig when you should have zagged. All right? Some of you are going to take an initial and put it in the final spot. Or you're going to take a final and you're going to put it in an initial spot. All right? So the final velocity, simply put, is the ending speed. But again, it's a velocity. So therefore, since it's a velocity, Michaela, then what do we measure it in?
Meters over seconds.
Meters over seconds. Oh, it sounds like she's asking me a question. She sounds like Marco Nahar. Every time he says something to me, it sounds like he's asking me. What does VF stand for? Final velocity? Is that your answer or a question? I don't know. So, everybody good right there with initial and final? Yes? No? Yeah? Okay, you ready? Here's again, because we realized this the other day that some of you do the wrong thing. VF minus VI. Okay? The final minus the initial. The ending minus the starting. Okay? So, here's what I need to make sure. Okay? We are out of second grade. So that means you ain't just going to take the bigger number and put it there. Because in second grade you learned when you subtract, it's the bigger number first minus the smaller number, right? Well, guess what? We're in high school now. We can get negative numbers. So we can have that number there be smaller. Because if I slow down, right? Let's say this. I'm going 20 miles an hour now. Sorry, I said that wrong. I'm going 10 miles an hour now. But a while ago, I was going 20 miles an hour, right? What was my VF, my final velocity? 10. What was my VI? 20. 10 minus 20 is what? Negative 10, right? I can get a negative, because didn't I tell you in the previous set of notes right here that if your acceleration is negative, what did that mean? You slow down. Well, didn't I just say I slow down? So that's why You can't just go here and just say, I'm going to put the bigger number first and then just do a subtraction thing because we're not in second grade anymore. All right, so just remember that. T, if you don't know this, you did not pay attention to anything we did yesterday. Stands for what? Time. Oh, battery low. Sorry, I got an indicator on the iPad. What do we measure time in? Seconds. All right, and so now the last thing is acceleration. What do we measure acceleration in? Is that? There ain't nothing on the board that you measure acceleration in. No, I meant the unit. The unit.
M over S squared.
M over S squared. Okay? Now, you ready? Here's where I'm going to hurt some of your feelings. Okay? But don't blame me. Blame your math teacher. How many variables in this formula? 4? Okay. How many sides to a triangle?
3.
That's why I can't give you a triangle. Okay? So right now, if it ain't set to solve for acceleration and you don't know how to do algebra, then right now you're going, thank God Mr. Science gives us the partial system credit, right? The 3-step process. Because as long as I pick this right and I list these right, then I can still get 2/3 of the problem. Because when I get the algebra part, some of you ain't going to know what to do. Okay? So that's why I'm just letting you know. There is no triangle here. Can't give it to you. All right? So just letting you know that. You just either can do it, either you can or you can't. But that's why you might want to make sure you do your 3-step process then in case you suck at algebra. But that's only an issue if you have to solve for this, this, or this. If you're solving for A, then you do that minus that divided by that. But anything else, you either have to know how to work it out or you don't know how to work it out. All right? Does anybody have any questions of what's on the board right now? Okay. Let's take a look at a problem. All right? And again, just like yesterday, I do want you to write this problem down. All right? I believe I had Mr. Victor. Remember how to turn on that projector? Yeah. Could you do that for me, please, sir? Victor, are you like me or are you not like me? My question is this. You always look like you want to murder somebody. You know what I'm saying? But, you see, people always think the same thing when they look at me. They always think, man, he looks like he's talking all the time. You know what I'm saying? But I'm not. It's just the way I look. Now, my question is, do you want to murder somebody or is that just the way you look? Like, you good, but you just look that way. You good. Okay, I didn't know. You know what I'm saying? Because I was looking at him going, you know what? I probably don't need to make a joke about him because he's probably going to stand up and throw a punch. You know what I mean? Because I can't tell if he's just angry or if that's just the way he looks. Like, I just look angry. And I like it. Because in the hallways, people don't talk to me. Because they like, I ain't talking to him. Man. He looks mean. Good. Leave me alone. All right? That's why my door always closed. Even in the morning. It's closed. I don't want people walking in here. So, Renee. Hey, orale. That is named after your brother. FYI. All right? Yep. Renee is running on the track. Remember, you write this one down. Escribe. All right? You write this. You got to have an example in your notes to look at later on today. Okay? Got it? Well, hold on. Remember now, you ain't got to do nothing. All right? So I'm just saying, I recommend you write one down so that way when you got something to look back at, you got something to look back at. Renee is running on the track at a speed of 4 meters per second. He spots a hot chick in the stands and speeds up to 9 meters per second. Because now he don't want her to think he's slow. So now he actually tries. If it took 2 seconds to build up his speed, then at what rate did he accelerate? All right, so that's what we got. That's the scenario going on. He's running on the track, doing his thing, but then suddenly he sees somebody watching. And she looks good. So he wants to fool her by thinking he's actually good at what he does. So he starts to pick up speed. The question now is this. He picked up speed. Now we want to know is, so what is his acceleration? Because his acceleration is not going to be 5 meters per second. That was the increase. But the rate of increase, in other words, if I have a car that can get me from 0 miles per hour to 60 miles per hour, and it can do that in 4 seconds. Now, some of you probably don't even know whether that's good or not. Okay? but some of you might know. If I can go from 0 to 60 in 4 seconds, is that a fast car?
Yeah.
Yes, it is. The change in speed was 60 miles per hour, right? Because you were at 0, now you're at 60. Well, if I got a car that can get me from 0 to 60, and it takes me 1 minute and 40 seconds to get there, is that a fast car? But it was the same change in speed. You see what I'm saying? Like, there's another factor here. How long does it take? That's why acceleration isn't just the change in speed. It's how long does it take for that to happen. All right? So the car that takes 4 seconds to go from 0 to 60, trust me, is going to be more expensive than the car that gets you to 0 to 60 in 100 seconds. All right? That's just kind of how it is. Because the acceleration is greater for the sports car than it is for my hoopty. All right? So, yesterday, I could tell some of you are still writing, but some of you will catch up. Yesterday, what did I say is the first thing we got to do when we get this question? Not the variables. Find the question first, right? And how do I know which is the question? It's simply the one with the question mark, right? So, let's go to Medieval. What is the question? Like in all this wordage, what is the question?
At what rate do you accelerate?
Okay, so therefore, what is the acceleration, right? Remember those 5 formulas I had you look at yesterday? Okay, ready? Let's look at them again. Because this ain't as easy as you think. Because all we're learning right now is just one formula, correct? Okay, the first one, V equals D over T. Does that have acceleration in it? No, so I'm not using it. The second one, does it have acceleration in it? There's one. The third one, does it have an acceleration in it? Yes, there's your second one. The fourth one, does it have an acceleration in it? You sure? What does the G stand for? Acceleration. So does that got acceleration in it? Yes. So how many formulas have acceleration in it? 3. So which one are you going to use now? So how do we fix that issue? What did I say we do yesterday? Once I know I got 3 formulas now I got to decide on, what should I do next? What did I do yesterday? Think about it. What did I do yesterday? You can't remember what I did yesterday. You don't pay attention to me. You never listen. I went up here and I started circling numbers. There's that. There's that. There's that. Right? That's what I started doing. And then after I circled them, then what did I do? I didn't charge no formula. I still don't know what formula to use.
Oh, you see what?
Which one?
You see what variables you had in the problem?
Okay, so here we go. I got that. What's that? Velocity? Great. I got that. What's that? Velocity. All right. I got that. What's that? Time. And I'm solving for acceleration. Well, which acceleration has got velocity and time in it? Y'all like allergic to saying these formulas. A equals VF minus VI divided by T. All right? So now that's the one I'm going to use. How do I know? Because it's got velocity in it. I have velocities. It's got time in it. I got time. That's makes your life a whole lot easier when you know what you're looking at. But again, if you still are not learning these units, you still don't know what you're looking at. Okay? You still don't know what you're looking at. So, now we're going to list our variables. All right, and now that I'm listing my variables, let me throw it over here. Coburn, what am I going to put for A equals? I mean, like, A equals, what should I put there?
Nothing.
Nothing? What do I do? What do I put there?
X.
Oh, yeah.
X. All right, there you go. Coburn. Coburn was just like, you remind me of this student I had that was like, because where were you yesterday? You were, yeah, okay. Like, you always seem like you're like a minute behind everybody else. But even though you're a minute behind, you end up being right. You know what I'm saying? So I had somebody else like that. I called him half step though, because he was always a half step behind. So like he'd get my jokes, but it was usually like 45 seconds later. So like we moved on, suddenly he started laughing, and the class would be like, "What the heck?" You know what I mean? But he was just half step slow. All right, VF equals Jayla. Since this deals with acceleration and running, you know, you may be running. What is VF? What am I gonna put for VF? 9. Okay, she's gonna put 9 because it's the bigger number. Oh, okay. Good, you're right. Because we're not in second grade anymore. Even though some of you have math skills at about a second grade level. Okay? Now, I told you. 20 minus 2. And somebody had to go to the calculator and do that last semester. Alright? Nate, what am I doing for VI?
4.
4? For what?
Meters over second.
4 meters over second. Let's get used to saying these units, you know what I'm saying? Because I need to burn it in your brain. Alright? Barney, T equals, what am I putting? 2 seconds. Where you're like a step behind. You know what I mean? Like you're a minute behind. It takes him a minute to get there. Like he starts on time, but it just takes him a minute. You know what I mean? 4 plus 6. 4 plus 6 is 10. He got it in the brain. He's just slow in the delivery. All right, now Barney. What am I going to do? Oh, it's hard to tell for you what to do, right? So we're going to rewrite this whole thing. Rewrite this whole thing. We got x equals 9 minus 4 divided by 2. All right? And so when you do that math, obviously, if you do it step by step, Makala, 9 minus 4 is what? Mahaka. Little. 9 minus 4 is what? 5. Then we're going to do 5 divided by 2. Okay? We do 5 divided by 2. Kevin, what do we get? By the way, I didn't realize I taught your sister second period. I didn't know I taught your sister second period.
2.5.
2.5. So our acceleration is 2.5. And then, George, 2.5 what? And it's okay to look at your notes if you got to. That's why we're doing this. This is why it's practice. Look at your notes. Sir? Close. I think you said it right, but you said it the other way that I'm not used to. So m over s, I think you did s, but m over s squared. Okay, so that's your acceleration. And remember, the reason why we got to be careful, m over s is velocity, m over s squared is acceleration. Are we good with that? All right. This concludes the recording of this video.